There's quite disturbance.
Shiv Jan, please mute yourself. Shiv Jan.
Yes, sir. Yes, sir.
Sir,
Sir,
who is going to take the class, sir?
Actually, the sir is yet to join this meeting, I think. Sir will take the class one.
Just
Hello.
wait, I think sir will be back soon.
Hello. Am I audible?
Yes, sir. Good evening,
Yes,
sir.
sir.
Okay. Yeah. So, good evening, all of you.
Good evening, sir.
Good evening.
Good
So,
good evening, sir. Good evening, sir.
yeah. Good evening to all of you. So, today's agenda, like we are going to discuss the content of week 4. Okay.
Excuse me, sir.
So, fine. Okay. So, one more thing I wanted to just
Excuse
to
me,
all of
sir.
you.
Am I
Uh,
audible?
yes.
Sir, we have received the assignment for week 5. Should
Correct.
we submit that?
Correct. So due date is 14, right?
Yeah.
Yeah. So you have to do. Okay, actually, because see, every Friday we are releasing the content for week 1, week 2, and week 3, and so on, right? Suppose you qualified, then you want to continue, then you have to submit the assignment. Okay. Anyway, it's the due date is 14th July, right? And your qualifier
Sir,
exam is on 7th July. So you
Sir,
can
what
submit.
will happen if we miss any one of the graded assignment? What will be its impact?
You should check the grading document lecture, right? So it's clearly mentioned how many activities we are going to take and also everything. Okay.
hello,
So you
sir.
can,
So
there
it
is
means
Yes,
we have
sir.
background,
to
lots of
submit the
background
week
noise. You
5
should
only
go at
after
some.
passing the qualifier
Sir,
exam, right?
Yeah, so week 5, see, your exam will be, I think it's on 7th July, right? Then
Yes, sir.
due date is 14th July. So you can submit your assignment. That's not a problem, right? Even you are, see, result will be later.
Yes,
We don't
sir.
know what will be your result, but you should submit. Suppose you pass the qualifier, then to continue the course, you should submit, right?
So it
Did you
means
get
we
it?
have
Yes,
to
sir.
submit the week 5 assignment only after passing the qualifier exam.
See, you can
So,
submit now itself. You can submit at 8:10 also. That's not a problem. Okay. It's up to you. Okay. 7th July is the exam. 14th July is the due date. After giving them, you will get the result and you can submit the thing. But I will recommend you to watch the lecture video and submit the assignment. Anyway, if you're learning something, that's not a
Sir,
problem. Okay.
Sir,
no,
after how many days we can
yes,
expect the
sir.
result?
Two days, I think 2 or 3, then not more than that.
Okay.
Anyway,
hello.
see, if
Thank
you are learning something,
Hello,
it's not a
hello.
problem.
Sir,
Right?
you
I
are
can.
audible very low.
Sir,
So, sir, can you
Hello,
repeat
sir.
what you said earlier?
So yeah, okay. So what I would suggest, so one thing I wanted to discuss to all of you. See, today we will cover the summary of week 4. All right, and Sunday we will be having the session for activity and practice. So what I'm planning. So anyway, we have to take the revision session for qualifier. Okay. So what I'm thinking, if we can release the solve with the PDF earlier, right? Rather than discussing in that session, will it be fine to all of you? When we are going to take solve with the session at the same place, we can revise the concept of, or we can take a revision session. Will that work?
Yes, sir, yes, sir.
Yes,
Hello,
sir.
sir.
Yes, sir.
Hello,
No
Fine.
sir.
Sir,
problem.
you release the
Yes, sir.
PDF beforehand, then take doubts in that session if we had any.
Yeah.
Yes, sir.
That's what. Yeah. Okay.
Sir.
Yes, sir.
Yes,
You
sir, I
release
have
the
any
PDF
doubt.
beforehand.
Hello,
Along
sir.
with along with solution, we'll release the PDF.
Yes, sir. Yes, sir.
Hello,
If
sir.
doubt happens, then please clarify in the another session.
Yeah, one by
Hello,
one, one
hello.
by one
Hello,
by one.
sir. Sir.
Sir,
Sir, I have.
See, one by
basically the
one.
next solve with the session, we'll be revising the whole concepts, right?
Solve with the session is similar to graded assignment. That's why we are discussing one day before due date of graded assignments. So what
What the
I'm
phase
thinking,
one is the
uh,
what is the syllabus?
Revision.
okay. So what I'm thinking, uh, like
Yeah.
Tuesday session, right? 6 to 8, we can revise the.
Yes,
We
sir.
can take a revision session.
Yes, okay.
Okay, fine.
Sir,
Will that
also I
be-
had a
Yes, sir.
doubt.
That is a good idea, sir.
Sir, I had a doubt
Sir.
in week 3
Hello,
graded
sir.
assignment.
So,
Sir, I have only
yeah,
one
Sir,
doubt.
I have a doubt also.
PYQ also.
one second. So PYQ will be handled by TAs. Okay? That's because we have limited session, so we have to do the things accordingly.
Sir, I have a doubt in week 2 assignment. Can you please tell me?
Okay, so first I will discuss the week 4 concept. Only then I can do, because anyway you have to submit the week 4 assignment also, right? So
Sir,
first I
then
will
you
Before
discuss
start
the
taking
week
the
4.
week 4 assignment, I have
Will
a
this
little
4 week
doubt.
content be enough for passing the qualified exam?
Yes, content, practice assignment, grade assignment will be enough.
Hello, sir.
Okay. Yes,
Okay.
yes,
Sir,
you.
how
So,
will
sir,
we submit
Sir,
the
I have only one
EMA
doubt.
questions?
Yes, you. Yeah, please go ahead.
So when we will
sir,
get the hall ticket?
sir, can you please tell me where we got the PYQs?
PYQs, I think you can search any, or else we'll search and we'll ask to TAs. They
Sir,
will
I have a
respond.
link of the PYQ. I'll put it in a chat, okay?
That's fine. That's fine.
Yes.
Yes,
Prashant,
you were asking something. Okay, one second. Let me.
Sir, I am from
What is the plan today?
I'm going to discuss summarize the content of week 4. Will that be fine?
Okay, so you're going to give an introduction on the basic summary of that.
Correct. So if all of you have watched the lecture video, I can take questions, but I think
No, that will be great.
No,
I mean,
sir,
because
no, sir, we need.
okay.
that will be
No,
great.
no, sir. No, sir. Sir,
Okay.
please, sir. Theory also, sir.
Okay, so
Not direct question, sir.
one second.
Sir,
Let
please
me
take
speak.
theory also, sir.
One second.
Sir,
Yes,
please, sir,
please
show me.
Shiv, please go ahead.
यस सर सर मैं जेई कैटेगरी से आता हूँ मतलब मेरा दिक्कत ये हो रहा है कि जैसे पहले मैंने लिखा था क्विज 1 नहीं होगा पहले अब मेरा क्विज 1 का भी दे दिया है लोग डेट और वहां दिखा भी नहीं रहा मैं चेंज भी करने का नहीं रहा
No, quiz 1 you have to give, right? Quiz 1 you can give.
मेरे को
प्रशांत।
देने से दिक्कत नहीं मैं डरता नहीं कोई चीज से मैं तैयार हूँ देने का फिर पता ही नहीं चल रहा है कि एग्जाम देना है कि नहीं देना है
Okay, so did you talk to the support team?
They don't.
Shiv, did you talk to support team?
Hello. मैंने मैसेज किया बट ईमेल किया बट
No. Just okay. What I will suggest you just call to them, right? Okay, just call them. They will. Okay. Okay. So I'm going to mute all of you, and then because there was some background.
Hello, sir. I have posted the link.
Make
Hello,
noise,
sir.
Everyone
Sir,
to
I have posted the link for the PYQs in the chat. Okay?
Hello.
Yes,
सर कांटेक्ट नंबर सर वो मतलब कॉल नहीं हो पा रहा सर आईटी मद्रास के कांटेक्ट नंबर पे हेलो
Send your
Guys.
mail to the
Sir, you are
support. They'll
muted.
reply.
Guys, time and again. Okay.
Send your
Sorry,
mail to the
I
support.
replied.
guys ask one by one. Please don't noise.
Hello, sir. I have one question regarding case grade. Is it safe to log in there?
Where?
Can
Yes,
somebody tell
Hello.
me?
Hello. Hold on. I mean, why is this always the case that we always have these discussions about qualifier, grade, everything, especially when during the session.
Stupid. I'm also
When,
thinking
I
the
mean,
same thing, man.
we are, the whole thing is this an instructor session, and you should actually appreciate the time of everyone is precious. It's not for the thing, and we get mails from the support team. Today also we got the mail from support team about dashboard is updated about the hall ticket thing and also about the center part, and this clearly it is indicated that before 3 days you will get the intimation about the hall ticket, and the support team has released a mail for the week 5 thing, and also they have released about the next step. When you qualify, then you will continue for week 5. If not, this thing they have written every standard. I see the dashboard is updated, the support mail is sending this thing, and apart from all this thing, for what I see is that I see continuously certain people are coming to this session and asking the same doubt. Even people are asking about placement. You are talking about the qualified thing, internship, everything is being asked where that doesn't even matter at this point at all. We get mail for
I'm really
everything.
sorry to interrupt you, but there are certain people, if you see the persons over there, you can see that there are certain specific people, those who are
Yes,
asking
I
this
think it's
only.
all right. Let them ask. It's a bit confusing for some
you are
people to
actually
understand
bothered
how
in
the course functions.
One second. So listen to me. What I'm suggesting. every time I'm saying, if any one of you have any general doubt and or anything, it's good we should discuss at the end of the session, right? Because see, we have limited time, right? 8 to 10 and all. So if we are going to waste our time to discuss the general thing, so it's not good
Hello.
for us. Okay. So we can
Sir.
discuss. It's not like we are denying to discuss the
Sir,
general.
ignore everything, sir. Just start. 1 minute has already passed, sir.
So
Week
Sir,
four
I have
content is very
just
important, sir.
one question, that is
Sir, it
that
is
in
necessary
the
to give a
Sorry,
J-based
sir.
No question, sir. Sir, mute
Yes,
everyone,
sir.
sir. They are still asking
Sir,
just
please
JE
continue
questions.
with the session, sir.
okay, all right. So I'm going to discuss the content. Okay. I don't want to anything like you should list the concept wise thing. Okay. So I'm going to start the discuss the content. Rest general doubts and all we can discuss at the end of this session. Okay. I'm hoping it is clear to all of you. Also, yeah. So for this kind of general things we can discuss at the end of session. Also, you can talk to support team. Okay. If you are not getting the reply of mail, sometime you can call to them. Okay. So I'm going to share my screen. Okay. So do let me know if it is visible for you. Okay. Is it visible to all of you? Okay. All right. Yeah. Thank you. Okay. So till week 3, right? So if you have seen, okay, in week 1 we started from what is the statistics, right? We discussed what is the data, and we saw in statistics there are two kind of statistics, right? Descriptive, inferential. Then we move on the types of variables. Okay. Under types of variables we saw categorical, we saw numerical, and then kind of time series data, cross-sectional data, structured data, unstructured data. Lots of things we have seen already, right? Then in week 2, we discussed some like we saw something more about categorical data, right? Graphical representation of categorical data, measures of central tendency like mode and median for categorical data. I mean, lots of things, and that area principle and all we seen for categorical data, right? And then we in week 3, we have discussed about numerical data, right? We saw measures of central tendency, measures of dispersion, then we saw percentile, quartiles, IQR, box plot, outlast, lots of things we have seen, right? Graphical representation for numerical data, right? Histogram and all. We saw stem and leaf plot also. So those kind of things we have seen. Now, see, you have seen two kind of variable as of now: categorical variable and numerical variable. Okay, and we discuss about single variable only, like let's say gender for categorical. Numerical variable we saw, let's say age, weight, and all, right? We saw some data. What then we have calculated what is the average weight or maximum weight of the population, and also those kind of things we have seen in numerical data, and those only for a single variable. But now we are going to move ahead, like one step ahead. So what is that? Now we are going to discuss about two categorical data. Okay. We will move about two categorical data. We'll see two categorical data. But if I have two categorical data, then I would be interested to know, is there any association between two categorical data? So I would be interested to know, is there any association between two categorical variables, right? So if yes, then is there any method to check that or not? Okay. So in week 4, we will start from here. We'll see, is there any association between two categorical data or not? Okay. So for this thing, what is the main thing? Okay. So any one of you can simply write in the chat box. What do you mean by the association between two things? Connection, relation. Yeah. What is the meaning of connection and relation? dependence, okay, similarity. Yeah, so how a variable is related to other variable. All right, so something like association means, suppose I'm going to change in one variable, right? Okay, change in one variable reflect the change in another variable. All right, so this is meaning of association, right? So there is some kind of dependency. Dependency means suppose I'm making change in one variable, that should reflect the change in another variable. That's the meaning of dependency. Otherwise, independent means if I'm going to make any kind of change in one variable, that will not going to affect the change in second variables. So association means it's simply how they are dependent to each other. Means if I'm going to make any change in one variable, how it will reflect the change in another variable. Now, I will move to the method part. Like suppose I have two categorical variable, then how will I know whether those two categorical variable are associated or not? Okay, so what is the method first of all? So there is one method. First one is called row relative frequency. Okay, and similar is another is called column relative frequency. So you can use anyone. It's not like you have to check with both method, row relative frequency and column relative frequency. If your condition is satisfied with anyone, you can proceed with either row relative frequency or column relative frequency. Okay. So what is the row relative frequencies? For example, I have two variables. Okay. First variable is first categorical variable is ownership of a phone. Suppose you are an analyst and you wanted to know whether ownership of a phone is associated with gender or not. Okay, so you can see ownership of a phone, there will be two categories, right? Either yes or no. And gender, I'm taking two categories, for female and male. Okay, so now you can simply see this ownership of a phone and gender, these two are categorical variable, yes or no? Because we can't perform any meaningful mathematical operation. Yes, correct. So ownership of a phone and gender, these two are categorical variable. All right, great. Now, so I'm interested to know whether ownership of a phone is associated with gender or not. Suppose you are you went to any school or any college and you took some data for that. For example, so I'm taking some data. Let's say this is hypothetical data actually. So suppose this is the ownership of a phone. So for this, what I have to do, I will make a contingency table. What, how I can make contingency, I will show you. So for this, this is two categories, yes, no, and another variable is gender, right? So for gender, we have female and male. Let me write now. So there is two things, yes or no. So suppose I got the data, I asked some student and I got the data something like that. Let's say some 10 female say yes and 34 females say no, and some 14 males say yes and 42 males say no for ownership of the phone. Okay. Now, this is called contingency table. Okay. So first of all, I have to make the total. So this total will be 24 and this total will be 76. Okay. And this total will be 44 and this total will be 56. If you see clearly, grand total, this is called grand total. Okay, is a 100. Now, if you can observe, okay, what is the method? Method I told you, row relative frequency. And what is the relative frequency? We have seen in week 2. Relative frequency is nothing but frequency divided by total observation. Now here I'm interested in row relative frequency, right? So I would be interested what is the row total, right? Row relative frequency. So what is the row total here? row total is 44. Okay. So what I will do to getting the row relative frequency, I will do 10 divided by 44 or not, right? This is the row relative frequency. So this is the frequency, and in row relative frequency, what we are doing? We are dividing frequency divided by total. Here I am interested in row relative frequency, so I will divide by row total, right? So here it will be 34 divided by 44. For this, 14 divided by 56. For this, 42 divided by 56. And for the last column, it will be 24 divided by 100, and it will be 76 divided by 100. Okay. So this is something you can calculate the row relative frequency. Okay. So now if suppose you are interested in percentage term, then you can convert these things in percentage. Let me convert in percentage. So this will be gender. Gender is female and male. Okay. So this is 44, this is 56, this is 100. So what it will be, okay, this is the total one. So last it will be 24%. If I will multiply with the 100, and because I wanted to convert in percentage, this will be 76%. Okay. And this will be 14 divided by 56. Let me calculate. Give me a second. 14 divided by 56. It will be around, I think, 25%. And 42 divided by 56, it will be 75%. What's the next? 10 divided by 44. So 10 divided by 44, it will be some 22.73. Yeah, let me calculate. 34 divided by 44 will be 77. No, so what is the method so that I can yeah, thank you, Sue. Yeah, so how I can proceed for this? Like, what is the method? How would I find the whether variables are associated or not? Okay, so there is something called, okay, one more thing. You can calculate the column relative. Okay, before going to the, okay, let me. So what is the method? Like, how would you interpret your result, right? So result is if all the row relative frequencies are approximately same for all rows, then variables are associated. Variables are not associated to each other. Okay, I will explain why we are saying if row relative frequencies are different. Okay, I'm just writing here are different, then variables are associated. Okay. Now, I mean, there is significant difference. There should be significant. So how will you compare actually? So this is something like that. You can see first row relative frequency is this one, right? This is the final row, and this is okay. If you compare all rows, right? This to this, or this to this, or this to this, something like that. So you can see, you can simply see all the row relative frequencies are approximately, they are very approximately same, right? Not there is not a significant difference, right? It's not like this is 22 and this is 12, something like that, right? So it's approximately same. So what you can conclude here, you will say then variables are not associated to each other. Okay, I will make a graph that will help you actually. So let me draw a graph that is called 100% stacked bar. So that is useful for in this kind of scenario. So suppose this is female category, this is male category, this is 0%, and top most will be 100%. Okay, this is called. So this is 100% stacked bar chart is helpful for when we have categories in a single bar, and we are talking about in terms of percentage. So here you can see what is the total percentage of female who do not own phone, 75%. Okay, so let me circle, suppose 75% is somewhat here. Okay, it this is red for no. Okay, and for male, sorry, for female it's a 77, for male it should be 75, so 77 will be somewhat here. Okay, for male this is the 75. Okay, and this is the 25 for male, and for female 22. So for male 25, for female 20. Okay, so green for S, red for no. Okay, now so this is this red is part 77% something, and this is 75%, and this is the 25%, and this 22 point something 73%, if I'm not wrong. Okay, so I told you the meaning of association, right? So I told you what is the meaning of association. If you are going to see the change in one variable, then it should reflect the change in another variable. Okay, now you can simply write in the chat box for my next question. So my question is, if I'm going to see the change in female to male, right? Is there any significant change in this red region and green region? Is there any significant change? No, no, right? Not a significant change, right? If not a significant change means if they are approximately similar, that means they are approximately similar, right? If I'm going to make a change in one variable and then there is no significant change in another variable, that means variables are not associated. Correct? Yes or no? Okay, yeah. So this means variables are not associated. When your variables will be associated, I will make the another graph. Maybe that will help you. Okay, just give me a minute. So this is female, this is for male. Okay, that's the reason actually behind while we are taking the. Okay, just give me a second. So suppose for yes, for female, let's say this is the percentage of yes. Okay. For male, this is the percentage of yes. And for female, this is the percentage of, green for S, red for no. Anything you can take, that's not a problem. You should try to understand. Now, if I'm going to see the change in this variable, right? I mean, if I'm moving from this to this, male to female or something like that. So can you tell me, is there any significant change in this red and green? Yes? Correct? Would you agree with me? So you can simply say there is a significant change in yes, in the variables, right? That means what? I will say variables are associated. Correct? So in this kind of scenario, I will say as variables are associated, right? So I hope you got the idea, right? So whenever we'll see, no, week 5 will be for in qualifier, only week 4 will be covered. Okay, till week 4 is the syllabus. So you can simply see, right? If I'm going to make a change in one variable, it should reflect a significant change in another variable. While in this graph, you can simply say, I mean, both are approximately same, right? I mean, there is not a significant association, correct? So that's why we are saying if row relative frequencies are approximately same, I will say there is variables are not associated with each other. If I will say row relative frequency are significantly different, then I will say variables are associated. Now, I talked about column relative frequencies also. So you can do column relative frequency also. So what is the difference? You can simply see for row relative frequency, what we did, we divided frequency of a single row divided by row total. Then what should I do for column relative frequency? Anyone? Anyone? What should I do if I want to explain the column relative frequency? Yeah, Afrin is saying 10 divided by 24. Correct. So because column total is 24, right? So I can do 10 divided by 24. Similarly, 14 divided by 24. And here it will be 34 divided by 76 and 42 divided by 76. And here it will be 44 divided by 100. 56. And then you can convert in percent and you can compare this column and this column. So there is no need to calculate both, right? Row relative frequency or column relative frequency. You can do either one in which you are comfortable. You can go with the row relative frequency or column relative frequency. Answer you will get the same. Okay. So what we concluded here, if row relative frequencies, here actually it should be or column relative frequencies are approximately same for all rows or for all columns, then variables are not associated to each other. If row relative frequencies or column relative frequencies are different, significant difference is there, then I will say variables are associated with each other. Okay, is this all right? Clear? Yeah, it will depend on the question also. No, it's not like question. It will be you to question will be simply you to find the association between two variables. Then you can simply you can use either one. Like you can go with the row relative frequency or column relative frequency. Okay. So I'm going to ask to all of you one question. Just answer me. If I will ask, suppose this is the numbers 10, 34, 14, 42 and 2476, right? If I will ask, what is the percentage of male who own the phone, then what will be your answer? I'm going to repeat my question. What is the percentage of male who own a smartphone? No, I'm talking about percentage. Correct. 14 divided by not 100. I'm interested in what is the percentage of male. I didn't say what is the percentage of person who own the phone, right? If I will talk about percentage of person who, then I'm interested in 24, right? I'm interested in, okay, so let me write the table again. Maybe that will help you. So this kind of question is important, okay? So this is gender, this is female, and this is the male, okay? So what is the number? 10, 34, 14, 42. So 10, 34, 14, 42. Now, suppose this is the contingency table is given to you. Okay, suppose this is 24, this is the 76, 42, 56, okay, 44, 100. Now, my question is, what is the percentage of male who own a smartphone? Then I'm talking about male, right? So I'm interested to know out of total male, what is the percentage of male who own the phone? It will be 14 divided by 56 into 100. Now, suppose my question is, what is the percentage of female who do not own a phone? Then what will be the answer? Correct. 34 divided by 44. Suppose what is the percentage of person who do not own a phone? Person I'm talking about. If I will say what is the percentage of person who who do not own a phone, then correct. So what is the total number of person who do not own a phone? 76. So it will be 76 into divided by 100 into 100. Okay. Okay, now I'm hoping you got the idea behind this. Okay. So next is something called bar chart. Stacked bar chart or 100% stacked bar chart. So stacked bar chart is nothing but it's similar. Like see, bar chart you have seen. So bar chart you have seen something like that. Let's say for female, this is for male. Okay. So what is the total number of female? 44. Correct. And male is 56. It shouldn't be like this. One second. Yeah, suppose scaling 0 and up to some 60, and this is the 56, and one second. Actually scaling should be properly here. Suppose this is the 60, this is 56, and suppose this is the 44. So this is the something called bar chart, right? We are interested to show the count of category, right? That is something we are using for bar chart. What is called stacked bar chart means there is partition. So partition means what is it? Aryan, what? I don't think you guys should these kind of things chat box, right? Okay. So what is the stacked bar chart? So suppose I'm going to, so we have two categories inside of for female, right? Two categories. There is 10 female who is saying yes, 34 who is saying no. So what you will do, you are going to split the things, right? Let's say for S, this is the 10. This is the female candidate who is saying yes, and male candidate are saying yes 14. Suppose this is the 14. This is the count, and so rest they are saying no. Similarly, they are saying no. Suppose this is 40. I mean, this scaling we have to do the properly. This might not be correct, but I'm just giving you a rough idea to all of you. So stacked bar chart is something I can split the thing, right? I can split the categories also. And what is the 100% stacked bar chart? I want to show the in proportion or in percentage. So this is called 100% stacked bar chart. Okay, so far so good. So friend, there is nothing in stacked bar chart. What we are doing, we are just simply see normally in if you can ignore this red part and green part. Okay, so this is called bar chart, correct? Right? I think Prajin, you should check your from your side. I think my voice is okay to all everyone. So this is called bar chart. So what is the stacked bar chart? We are just dividing the categories, right? So for yes, there is 10 female. For no, there is 34. So suppose this is the 34 female who are saying no for the phone. Like we are just doing this. We are just separating the categories for female. Okay. And 42 male, they are saying no. This is male. And you are just splitting the basically bars, right? How many female are saying yes, how many male are saying yes and no, something like that. And what is the 100% stacked bar chart? Here you are interested in count, and in 100% stacked bar chart, I'm interested in the proportion or in terms of percentage. So this is called 100% stacked bar chart. Okay. All right. Okay. Now, fine. Okay, so now till here you saw the association between categorical variable, right? But in week 3, we discussed about numerical variables as well. Okay. So now we will see what if I have two numerical variables. So I will see what if I have two numerical variables. So is there any way to see the association between two numerical variables? Anyone? Is there any way to see the association between two numerical variables? See, contingency table. Yeah, correct. Yeah, correct. So Lakshya is also correct, I think, and Shivam is also correct. Scatter plot and all. So correlation is helpful for to see the numerical, I mean, linear association between two numerical variables. The very first thing, what from where we are starting, we should plot a scatter plot, right? So what scatter plot does actually? So scatter plot gives us a basic idea about association between two numerical variables, right? So I mean, it will give you a very first like quick idea. I mean, if you have two numerical variable and you are interested to see whether those two numerical variables are associated, I mean, is there any linear relationship or not? So in stats 1 course, mostly we will focus on the linear association. Rest kind of association we'll see in other courses. So we'll see then how to do, like how to identify, right? Then very first thing called scatter plot. Okay? So scatter plot will give you the key idea about linear association, like what kind of association is there in for your two numerical variables. So suppose your two numerical variables x and y. So normally x will be independent variable, okay, and another will be dependent. Okay. See, only then it will be association. All right. So independent sometimes called explanatory variable. Okay, and dependent sometimes called response variable. These are just a different kind of names. Okay, so let's say I'm saying x is age. Okay, and y is weight or height. Now then you can quickly guess the idea, right? Age will be independent, right? Weight can be dependent on age. Yes or no? Right? Yeah, so how to identify, you to check, right? Which one is, which can give, let's say income and expenditure, right? So which one will be independent? Income, right? Correct. So income will be independent, right? So expenditure will depend on your income. Suppose your salary is 60,000, 50,000, and your then expenditure will be accordingly, right? Suppose your salary is 1,50,000, then your expenditure will be accordingly. So something you have to see and think which will be independent or dependent. Now, so normally we are denoting X as independent and Y is the dependent. So we'll see how to identify the association actually from the scatter plot. So how your scatter plot will look like? Suppose you have data of two variables, right? X and Y. Okay, means suppose X is let's say age of a person and Y is weight of a person. Okay, and both are numerical variable. You can clearly see. Then for let's say for age 20, weight is let's say 45. Age is 25. Some 5 people is there or some 10 people is there. Okay, then weight is let's say 50. Okay, age is 24, weight is let's say 45, something like that. It can be anything. So for, okay, so how we are I'm just giving you rough idea about the scatter plot. How will you draw a scatter plot? So this is called x-axis and this is called y-axis. So y-axis will represent the weight and here you will represent the age. So how will you represent? So for 20, suppose this is the 0, this is the 5, this is the 10, this is the 15, this is the 20, and this is let's say 10, 20, 30, 40, 50, and so on. It can be anything, right? For 20, it's a 45. So you will represent like this. So for 20, you can see the pencil. So you can something for 20, this is 45. Then for 25, it's a 50. Suppose 25 is there and 50 is there, right? So for 25, it's a 50. Correct? This is something you can do. You can ignore the dotted line. For 24, it's a 45 again. So for 24, it's a 45, something like that. Okay, okay, okay. So accordingly, you can plot, right? So this is something we are making the scatter plot. So I will give you the idea how we can interpret the something. So suppose this is x-axis, this is the y-axis. Okay. So you will tell me, suppose I plotted the graph and I got this kind of curve. Okay. So what kind of this curve is? Can you interpret something? What will be your interpretation? It's a linear, right? It's a linear, correct. It's a linear curve. Okay. Now tell me whether this is whether there will be something called positive association and negative association also. So this is positive or negative? Positive, positive, positive. Correct. So why is okay, what is the meaning of positive actually? So positive means if let's say x is increasing, y is also increasing. Yes or no? Correct. So here I will say x and y are positively related, right? So there is positive linear association. Okay. Now what if I will draw a graph like this? This is x-axis, this is y. Suppose I draw the scatter plot of the given data and got like this. What is this? This is negative and linear, right? Correct. So this is negative. So this is, I will say, negatively, linearly related. Okay. So what is the meaning of negatively? Means if x is increasing, y is decreasing. You can say, right? X is increasing, then y is decreasing. Or if x is decreasing, y is increasing, right? I mean, one is positive, another is negative, one is negative, another is positive. So this is something I will get some rough idea from the scatter plot. Okay, what if I got the something like this? Let's say I got the something like this. What kind of association is there? It's a curve, right? So this is not a linear. Correct. So this is not linear, right? Means I will say my x and y are not linearly related. There is some relationship, but it's a curve. I mean, we don't know exact relation. It's a curve. I mean, there is some curvy linear relationship is there, right? So this curvy linear relationship we are not going to study in stats 1 course. There is something called so for linear association we will see what is the correlation and all. And for curvy linear, you can search if you are interested to learn this advanced thing. So that is called something correlation ratio. You can search for this. But as of now, our focus will be on linear. Okay. What if I will, I got the scatter plot, something like this. So what kind of association or what will be your interpretation for this graph? Not really. Right. Correct. It's a randomly scattered, right? Okay. So it's a randomly no pattern, right? So I will say x and y are not related. Okay, all right. So this is the very first thing to get the idea about your whether your numerical variables are I mean, is there any linear relationship or what kind of relationship is there? If linear relationship is there, so whether it's a positive linear relationship or negative linear relationship or not. So those kind of thing. But here, okay. So from here you can say, see, this x and y are positively linearly related. For this, you will say x and y are negatively linearly related, right? But this is just a graph, right? Is there something I can quantify in number this positive thing, positive linear association or negative linear association or not? Okay. So answer is yes. Okay. Yeah. So Pranod, before going to correlation, we have covariance. Yeah, correct. Naya Praveen is correct. So before going to correlation, I will explain the reason why we are moving like this. So first is called covariance. Okay. So covariance is useful to it's a measure to measure the linear association between two numerical variables. Okay. And all of you, okay, so what is the covariance? So covariance, see, you have seen the formula of variance, like let's say sample variance and population variance. So similarly, we have formula here. So first one is called, let's say population covariance. Okay, very key difference is there. I mean, very minor difference. So population covariance will be 1 upon n summation I is equal to 1 to n. Since I have two variables, it will be xi minus x bar into yi minus y bar. And what will be the formula for sample covariance? So it will be 1 upon n minus 1 summation will be I equal to 1 to n xi minus x bar into yi minus y bar. The same difference, right? In the denominator part, as we have seen for variance, in the case of variance, it will be n and n minus 1. And similarly here it will be like same case, right? For population it will be n, for sample it will be n minus 1 in the denominator. Okay, one interesting thing you can uh, see here, like if, okay, normally we are denoting covariance as x comma y. Okay, so if I have covariance between x comma y, let's say I'm talking about this population covariance 1 upon n summation I is equal to 1 to n xi minus x bar yi minus y. Okay, one important thing, this is the x and this will be y. So covariance, but if I will write covariance between x comma x, then what it will be? Any guess? You can take one minute for this. My question is, if I will write covariance between x comma x, then what should I write? No, not 0. You are not thinking. Yeah, it is okay. So at the place of y, I will write x, right? So it will be summation I is equal to 1 to n xi minus x bar. It will be again xi minus x bar, right? In the at the place of y, I have x, so I can simply replace. So what I will get here? It will 1 upon n. Summation will be I is equal to 1 to n. It will be xi minus x bar square, right? Now, what is this? This is the sigma square, right? Population covariance. So you can simply say see covariance between x comma x. It's nothing but variance of x, right? So similarly, I can say covariance between y comma y is variance of y. This is just I wanted to give you some idea. Okay. Anyway, let's move our uh, main thing. So suppose I have x as a, let's say, age, and y as a weight or height, right? Now, what I told you, how will you, if you see the formula of covariance between x comma y, let's say population covariance, so it will be 1 upon n summation of xi minus x bar yi minus y bar. All right. So how will you compute, right? It's not I is equal to, it's for n, right? It's not I will be from 1 to n, not n minus 1. Everywhere I will be 1 to n, 1 to n, 1 to n. Okay. Is it clear? So for like if you're talking about these things n and like for this n and n minus 1, so I mean we are not going into the depth for this course actually, but you can search. There is something called degree of freedom, unbiasedness property, and all. So those things you will study in stats 2 course. As of now, what you can do, you can simply keep the formula in your mind. Okay, so that is something we are not going to study for this foundation course. Okay. So yeah, so what I was telling you, okay, so this is xi. So suppose this will be, there will be some data, right? Let's say 15, 20, 18, 24, and something, let's say 30. Okay. Then how you have to proceed here? If you can see xi minus x bar. So this is xi minus x bar will be, there will be one another column for xi minus x bar. And suppose for y, there is some data, let's say 30, 32, no, then some 40, then some 50, and then let's say some 52, something like this is data. So what you have to do, if you see the formula, you have to do yi minus y bar. Then first you will calculate x bar here. Then what you will do, it will be x 15 minus x bar, 20 minus x bar, 18 minus x bar, 24 minus x bar, 30 minus x bar. I mean, whatever the x value of x bar will be there. And similarly here, you can calculate, you will calculate 30 minus y bar. So y bar you can calculate from here. You can add all these value and divide by 5. Then similarly 32 minus y bar and so on up to 52 minus y bar. So what is the next? If you see in the formula, I have to add the product of these two, right? Product of these two. Then what you have to do? It will be xi minus x bar into yi minus y bar. So what is the next? You have to product. You have to do the multiplication of these two. Then whatever it will be, let's say I'm just for as of now I'm writing C11 and product of these two. Let's say C12. Product of these two, C13, C14, similarly C15. Then what you have to do, you have to add all these things, right? So let's say it will be summation of C11 plus C12 up to C15, right? These will be in numbers. Then how will you compute the population covariance? Don't worry about the population covariance, sample covariance. It will be clearly mentioned which one you have to calculate. It will be 1 upon n. So n is 5 and addition of all this. So C11 plus C12 plus C13 plus C14 plus C15. So you can calculate and you will get the answer, right? So this is formula of population covariance. Instead of this, if I will mention what is the formula of sample covariance, then you can simply tell me it will be 1 upon n minus 1. So it will be 1 upon 4 C11, C12 up to C15. So what is the thing we have to check here? See covariance. Okay, first of all, what kind of values you will get for covariance, whether it will be always positive or it can be negative or anything else. Correct? Positive, negative. Yeah. So my question is, covariance will be positive or negative, or it can be anything. No, it's not about positive. Positive or negative, it can be anything, right? So you can see it's a multiplication. So it's, okay, in case of variance, it will be always positive because it's no square of things. Suppose you got minus 2 square, you will get always positive. But here, suppose this is the positive and this is the not here. Suppose in this case, xi is I mean, you got xi minus x bar in positive, yi minus y bar in negative. Then it will be negative, right? It can be negative, right? Variance is always positive, correct? So it can be zero also. Covariance can be zero also, right? Product of these two can be zero also. It's not like that it can't be zero. Okay. So covariance can be anything. Like it can be positive, it can be negative, it can be anything. Okay. So thing is that how will you interpret? Okay. Suppose for a data set, covariance x comma y you got, let's say 152, and for another data set covariance x comma y you got 75. For a data set covariance x comma y you got minus 78, and covariance between x comma y you got minus, let's say, 20. Okay. So but thing is that just to give me a minute. Okay. So my question is to all of you. So then say why we do n minus 1 in sample covariance or sample variance and all. That's why I told you we are not going to discuss the reason behind this. It's a little bit advanced. Those kind of things you will see in stage 2. But if you are interested, then I will give you the idea. It's something called degree of freedom, unbiasedness property and all. Those things we have to see, but it's a little bit advanced topic. That's why we are not going to going there. Okay. So my question is, can you comment something by saying the value? See, I know if you see covariance is 152, then you will say, yeah, variables are, there is positive linear relationship. Yes or no? For this, again, you will say the positive linear association. Correct? Here you will see negative linear association. Correct? Here I will say negative linear association. Yes or no? So these kind of things I can see. I can say about the linear relationship between the x and between the y. All right. But my question is, but can you say? Can you tell me which one is the strong one? Like which one is the high? More strength. Which one is the strongly? There is strong positive linear association, and which one is the when I will say this is the strong negative linear association, or there is a weak positive linear association. Okay, 152. Suppose I wrote I wrote 180, then it can be 200. Correct. It can be 1 also. Covariance between x comma y is 1. Okay. So actually, when you will say which one is the strong or which one is the okay, so you can't say, right? Suppose for a covariance you got 500, something like that, but you can get any number, right? In negative also. So thing is that we don't, why we are saying we don't have any upper limit and lower limit. Okay. If you have, let's say you have boundary, let's say we are saying we normally we are okay. Before going to that, suppose I'm saying covariance between x comma y is 0, then what will be your interpretation here? No linear. No. You can't say no relation. You will say no linear relationship, right? Okay. There might be another other relationship also. It can be, let's say some quadratic relationship can be there. But if I'm saying covariance is 0, then I will say there is no linear relationship. There might be another relationship. Say correlation is -1 to 1, not 0 to 1. Okay, let me give you one idea. Why is the region? I mean, what is the region actually? Just give me a second. Suppose I'm going to share my screen. Maybe this Google Sheet you can see. I'm just going to write some values. Okay, let's say I have, -3, -2, -1, and let's say 1, 2, 3. This is my x random variable. And suppose I have y, let's say 9, 4, 1, then 1, 4, 9. Okay. So now what I will going to explain you here. So let me find the covariance. Okay. So covariance between these two variables is 0, right? But here you cannot say x and y are not related. They are not linearly related, because if you see, if you can observe clearly, so what is this 9? 9 is nothing but square of this, correct? Would you agree with me, all of you? If you see the highlighted column, right, C column, so what is this y? Y is, there is a relationship y equal to x square, correct? Okay. Now, so for this kind of data set, I got covariance is equal to 0, but I cannot say they x and y are not related at all. We can't say these things, right? Only we can say x and y are not linearly related. Okay, I'm hoping this is clear to all of you, because there is linear relationship y equal to x square, and for this I got covariance between x comma y as a 0. So I saw there is no linear relationship, but if we can't say those two are independent at all. I mean, there is no relationship at all. We can't say. Okay, so come to the back. Okay, its graph is not correct. So come to the back thing, this let's say this covariance thing. So I was telling you, right? So we don't have upper limit and lower limit. We can't say which one is the strongest, right? We can't make any judgment, right? So and first of all, this will be a unit also. So what next comes into the picture, that is the called correlation coefficient. Okay. This is called correlation coefficient. Actually, correlation coefficient will tell you the strength of your linear associationship. Why? I will tell you. So, formula for correlation coefficient is normally we denoting R as a covariance between x comma y divided by standard deviation of x into standard deviation of y. Okay. Now, one more thing I would say. Okay, tell me. And first of all, correlation is a unitless measure. Why is that so? So you can see, if I will say, what is the formula of covariance between x comma y? Let's say I'm talking about population. So it will be 1 upon n, xi minus x bar, yi minus y bar, right? Suppose x is age, y is the weight. Then what will the unit in the numerator part? What will be the unit in the numerator part? If x is age, y is the weight. Correct. Year into kilogram. Correct. And what about standard deviation of x? If you talk about unit, again I will get year. Standard deviation of it will be kilogram. So you can say it will get cancelled out. Okay. So one more thing we can say, R is unitless measure. Okay. And R lies between -1 to 1. Okay. So this is something. If R is very close to 1, I will say there is a strong positive linear relationship. Okay. I will write the some region, and R is -1. I will say strong negative linear relations. I mean, see, linear relationship can be positive, negative, but whether it's a weak or what kind of association, whether it's a positive, strong, or something like that. Okay. So one more thing, while you are going to calculate the correlation coefficient, you can keep one more thing in mind. So R is what? Covariance between x comma y divided by standard deviation of x into standard deviation of y. So one more thing, if you are going to use the formula here, see, normally for the correlation coefficient, there is nothing called population correlation or sample correlation. There is this formula. Okay. So if you are going to use the population covariance in the numerator, make sure you are going to use the population standard deviation for x, population standard deviation for y in denominator also. Means if you are going to use population part in covariance, then it will be population in the denominator also, numerator and denominator. If you are going to use sample, then it will be sample. I mean, both numerator and denominators you have to use. So I will give you one formula. So for population, suppose I am writing 1 upon n summation of xi minus x bar into yi minus y bar. Divide by what will be the standard deviation? So it will be population. So I will write xi minus x bar square root of 1 upon n summation yi minus y bar square. So you can see, if I will take square root of 1 by n, so this will get cancel out with this, correct? Because square root of 2 into 2, it is nothing but 2. So similarly, square root of 1 by n, square root of 1 by n, it will be 1 by n, and denominator and numerator will get cancel out. And if you are going to use this, sample correlation sample covariance formula or sample variance formula, then it will be n minus 1, n minus 1, n minus 1. Again, it will get cancelled out. So final formula for correlation coefficient, you can use directly summation of xi minus x bar into yi minus y bar divided by square root of summation of xi minus x bar square and summation of yi minus y bar square. I hope till now this is the clear to all of you. Also, you can expand this formula, right? You can simply do this multiplication of this, then it will be summation of xi yi minus something x bar n times of x bar y bar, something similarly in the denominator. So you can keep this formula in your mind. And what is the range? Range for R is -1 to 1. Okay. So another thing, I'm going to write to the things when it will be strong, positive, strong, moderate positive or weak positive and all. You can write with along with me, or you can take a screenshot for your reference. That will help you for graded assignment also, because there is one question. Yeah. So it will always be written correlation always, right? So that's why I told you, right? There will not be anything population covariance, sample covariance. The final formula is this one. Okay. So you have to keep in your mind one thing. You can directly use this one, or else suppose you have remembered this formula, then but make sure in the numerator you are going to use the population covariance, then in the denominator use the population standard deviation for x and y also, right? Don't do like in the numerator you have used the population covariance formula, and in the denominator you have used the sample standard deviation for x and y. That will not give you a correct answer. Okay. So if you are going to use population or sample, make sure you are using in the denominator and numerator the same thing. Okay. As you can see here, if I have used the sample, then it will be n minus 1 and n minus 1, and both will get cancelled out, and I got this final formula. Okay. All right. Yes. Pearson formula we have to yesterday here, or going to read it. So next thing I'm going to write the, like, when it will be strong, when it will be moderate, when it will be weak. You can take a screenshot, or you can, if you have pen and paper, you can write along with me. It will help you to answer some questions from graded assignment. Okay. So if suppose you have calculated the value of r and your r is lying between 0.75 between 1, then I will say there is a strong positive linear relationship between my those numerical random variables x and y. Now, if I will write, if I will get the value of r less than 0.75, I will say moderate and positive. So moderate and positive linear relationship. Okay. Now, if I got the value of r from 0.25 before 0.5, I will say it's a weak and positive linear relationship. Okay, so you can see till now it's a positive, but for some value of r, I will say, yeah, the positive linear relationship is there, but it's a strong positive linear relationship is there, right? If r is there from 0.25, no, this it depends on the which value you got, right? Okay, it will depend on the what kind of value you got. So you can see r is lying between from -1 to 1. Okay, so I wrote till now for positive 1. If your value of r you are getting minus 0.25 between and plus 0.25, you will say there is absence of linear uh, relationship. This is something you will get some sort of idea whether what kind of linear relationship is there. Now, if you will get minus 0.5 minus 0.25, then you will get it will be weak and negative linear relationship. So here you got you see, yeah, it's a negative linear relationship, but it's a very weak negative linear relationship, right? Then I will say minus 0.75 to r and up to minus 0.5. I will say there is something moderate and negative linear relationship. Okay, and if minus 1 r to minus 0.75, then I will say strong and sorry, not positive, it will be negative linear relationship. Okay, all this all things will be linear. Okay, so you have to make sure all are linear. Okay, so this is something you can keep in mind. This will give you a rough idea about the what is the strength of your linear association between two numerical variable. Okay, so there's something. Okay, you can get this. Okay, I'm stopping for a minute here, and you can take the screenshot for your reference. All right. Okay, Nayab example, Parveen, I will give you example. Okay, let's say you have calculated the for any kind of day. Okay, let me take some random example. Maybe that will give you the idea. Okay, let me take one example. I will explain from. Okay, I will stay for here for a second so that you can take a screenshot or something like that, so that you will get idea, and then I will take an example for the same thing in after 2 minutes. Okay, I'm hoping will that be all right. Okay, all right. So I'm going to take one example and I will solve through the Google Sheet so that it will save time for us. Okay. Yeah. So I'm hoping you took the screenshot here, right? Correct. Yeah. Okay. All right. Great. Okay. So this is the Google Sheet. I'm going to. 1 second. This is visible to all of you. 125%. This kind of zoom in. All right. Okay. Yes. Fine. Okay. All right. So I'm just taking some random values. Let's say this is the 65 and 66, 67. Again, let's say 67. I'm just taking some random things so that 69 and 70 and let's say 72. I took some 8 values. So this is, suppose this is your x and this is y. 67 and 68. Let's say I have 65 and then I have, let's say 68, then 72, 72. All right, then let's say 69 and 71. Anything, right? So I'm not going to. Okay, so there is two way, right? So you can calculate what will be your x bar. So there is a function average to calculate the x bar, right? This is 68. Now I can take the average for y. It will be something 69. Then what is the next? If you see the correlation formula, what I have to do for this part, summation of xi minus x bar into yi minus y bar, right? So what I will do, I will calculate. You can do xi minus x bar. You can fix this so that it will not be changed. So this is xi minus x bar, G column. H column will be yi minus y bar. Okay. So I am making the dollar signs to fix this 69. Otherwise, it will, what is doing 67 minus 69. If you will not keep a dollar sign, it will be 68 minus this blank. Then 65 minus next. So we have to fix. So this is something xi minus x bar, yi minus y bar. Okay. So if you will do xi minus x bar into yi minus y bar, this is something you will get. Okay, let's compute the covariance. Then I will move. So what will the covariance here? I mean, then what I have to do covariance? I have to add all these things, right? Xi minus x bar, yi minus y bar. Okay, this is 24. Suppose I wanted to calculate population covariance, then what it will be? What should I do? 24 divided by how much? Anybody? 24 divided by? If I'm interested to calculate the pop. Yeah, correct. 8. Yeah. So I have to do 8, right? So if you see, I got 3. Now the same thing I can calculate with the formula also, right? So there is one formula called covar.p. This will give you the population covariance directly in Google Sheet. So I have to select the data set. You can see this 3 is same as this 3, right? So you can go with the formula and you can go with this also. So what I'm trying to say, similarly, you can calculate denominator part. I'm not going to do right now this part and this part, and I mean you can take this. See, this is xi minus x bar, right? You can take let me do it right now. Xi minus x bar is square, right? This will be xi minus x bar is square, and this will be yi minus y bar square. So what I have to do, I have to add, right? So I have to add these things. So it will give you the addition of J1 to this. And what I have to do, I have to took the square root of this addition part, right? So this thing 36, and similarly you can, this will give you the square root of K10, right? That is the, so what is the next? So you have seen what is our formula? Formula is summation of xi into xi minus x bar into yi minus y bar. Okay. So what is the xi minus x bar into yi minus y bar? This 24 divided by, in the denominator, what I have to do? If you see, I have to multiply by square root of these two, right? You see, I got r as a 0.60. This is one more thing. Another thing, I can calculate correlation with the There is called CORREL formula in the Google Sheet. And if I will select this data set and this data set, you can see I got the same value, right? So either you are going with the formula or this one, but in exam you have to do like this. You have to calculate all these things, this thing, this thing, this thing, this thing, then you will get the value. So you can see R is coming out to here 0.60. So if your R is 0.60, then what will be your interpretation by saying this value? What kind of linear association you will say? No, not a strong and positive. Moderate, yeah, correct. Moderate and positive. See, 0.60 will be this for this range, right? All right. Okay, is this clear, right? So far, so good. Correct. Yeah. Yes. All fine. So I'm going to give you one more idea so that you can get idea whether it, association will be positive or not. Okay. Then let me draw a graph. Just give me a minute, so that it will give you the idea. Suppose this is x-axis and this one is the y-axis. Okay, and suppose this is x-axis, then I'm assuming x bar will be somewhat here, and let's say y bar is somewhat here. Now suppose this is your y bar and this will be your x bar, and some kind of data set I have like this. Something like this. I got the data set like this, and this x bar, this line will represent x bar, this line is representing y bar. So what is the interesting part here you have to observe here? Suppose, okay, tell me what will be the value of xi minus x bar here? Value means whether it will be positive or negative in this region. Negative. Pavani Sharma is saying negative. Okay, Chiti is also saying negative. So in this region, xi minus x bar will be negative, right? It will be value of xi minus x bar will be negative. What about yi minus y bar? Negative or positive? Negative, right? Okay, so why negative? You can think, right? See, it's a xi minus x bar. So it's the left side part, right? You can think, you can put any value, you will get the xi minus x bar negative. What about this part? If xi minus x bar positive or negative? Positive, right? For this it will be positive, and here yi minus y bar, it's the negative. You can think about it's below that y line, that's why negative, or else you can put substitute any value and you will get the idea. And what about this part? Xi minus x bar will be positive because it's the above side also, and yi minus y bar will be positive, and here xi minus x bar will be, what should I write? Negative or positive? Negative, right? And yi minus y bar, I have to write positive. So what is the key thing? You my question is, what about, tell me, what will be product of these two in this part? Product will be positive or negative? Positive, right? Because multiplication of two negative numbers will give you the positive, so it will be positive. What about this part? Product of these two will be positive or negative? Negative. Great. What about this part? Product will be positive, and this part, product of these two will be negative. Now if you see the covariance formula, right? So in covariance, it's the summation of xi minus x bar yi minus y bar. So actually sign of correlation coefficient, it also depends on the covariance, because if you see this formula of correlation, so it will depend on the sign of this, because anyway this denominator part will always be positive. So you can simply get the idea. Now here I'm hoping you got the idea when it will be positive and when it will be negative. All right, is this clear so far? Okay, yes. All right, great. Okay, yeah. Okay, now great, fine. Yeah, okay, understood. So next thing is I will move a part called, okay, so far what we have seen, we saw the association between, two categorical variable, association between two numerical variable, right? See, these kind of things we have seen, right? This is something called bivariate and all. Okay. So, but what about if, see, we saw, one second, give me a minute. Let me scroll down. Yeah, YouTube link also there, right? You can check your calendar. You can, YouTube link is already there on your calendar. Okay, so you can check from there. Okay, yeah, let me finish the topic. Okay, so thing is that so far what we have seen till now, we saw association between one second. We saw association between two categorical variables. Okay. Next, after this, we saw association between two numerical variables. Means similar kind of variables if I have, I saw this kind of things. But thing is that, what if, is there any way so that, I can see the association between a categorical variable and a numerical variable? Okay. So this might be your next question, right? So far we have seen association between two categorical variables, association between two numerical variables. Is there any way I can find the association between a categorical variable and a numerical variable? So answer is yes, right? So with it's not like no, answer is yes. Okay. Okay, so before going to this, what I will ask to you, what if I will write covariance between gender and ownership of a phone? What should be your answer for this case? Correct? We can't say anything. You can't say not associated. No, you can't say anything, because covariance we are calculating for numerical variables. Okay, covariance tells us the association between numerical variables. If you talk about gender and ownership of a phone, then it's not a thing, right? So it's not possible, because for covariance we need numerical data. Okay, so these kind of basic thing you have to keep in your mind. Okay. Okay, so we'll focus on this part. So association between one categorical variable and one numerical variable. So I saw something on chat. Someone wrote about point-biserial correlation coefficient. Okay, so what is the thing? Okay, what is there any special property for this categorical variable? I mean, is there any something special we have to keep in mind for categorical variable? Yes, no? Yeah. It's not about ordinal. It should be only categorical. It can be ordinal, it can be nominal. It's not like it should be only two categories. We are talking about categorical variable, which will be having two categories. Okay, not more than that. Okay, I'm hoping this is the clear thing to all of you. Okay, now. So okay, yeah, it can be nominal, ordinal. It's not fun. Okay, so now my next question is, I'm interested to see association between a categorical variable and a numerical variable. Suppose I'm interested to see the association between gender and marks. Okay, so gender, let's say I have two categories, female and male, and marks have marks is marks. This is for I have this kind of data. Let's say female, let's say 68, male 50, female 92, female let's say 72, male 95, male 40. Suppose this is the data I have. Now here you can see, and I'm interested to find the is there any association between this gender and this marks or not? Okay, so this is called something point-biserial. Sometimes we are it will be clearly mentioned. It's absolute point-biserial, you can say. So what is the formula? RPB. We are at PB stands for point-biserial. So I will write y bar naught minus y bar 1. I will explain you the every notation. Divided by sigma x square root of p naught into p1. Okay, so what is the p naught here? N naught divided by n, and p1 is here n1 divided by n. Okay, so what is the meaning of y naught and 1? So we have two categories, all right, female and male. So we can code any category with 0 and another category with 1. So let's say I have coded female as 1, okay, and male as 0. Okay, now by this formula you will tell me what will be the formula. Suppose I am interested to calculate the p naught. So p naught means proportion of the male, right? So what is the n? Yes, for numerical data we will be availing two scales of measurement. N is not 1. N total number of observations 6, correct? So n is 6. N naught will represent the number of person or number of people which is, or number of categories which is coded by 0. So what is that which is coded by 0? 3, correct. So n naught is 3, right? You can see 1, 2, 3. So what is the proportion for male? I got half, that is 0.5. All right. What about this case? So total n is 6. Out of 6, you can say what is n1 represent the number of things which is coded with 1. So this is 1, 2, 3. Again 3 by 6, which is 0.5. This is a random data I took. It can be anything. Now, what is the next? Next is we have to calculate y bar naught. So what is the meaning of y bar naught? I have to take the average of those numbers which is coded with 0. So that means I have to take the average of this, and this. So it will be 50 plus 95 plus 40 divided by how much? What should be the denominator? 3 or 6? Somebody wrote 6. I don't know how. So average is something number addition, the number of, I mean, in the numerator part, how many numbers you are adding, divided by that numbers. Okay, I don't know the answer. Can be you can calculate. Okay, let me calculate. So it will be 50 plus 40, that is 90. I think 90 plus 95, 185 divided by 3, it will be some 61.67. All right. So what about y bar 1? So you can see y bar 1 is what? 1 second. So y bar 1 will be, mean of those observations which is coded with 1. So that means this. That means mean of this thing. Okay. So mean of 68 plus 92 plus 72 divided by 3. Okay. So you can calculate this value, 68 plus 92 plus 72 divided by 3. So it's 77.3. Okay, so one thing you can you can keep in your mind actually. So you can see here y bar naught is less, right? 61, and y bar 1 is higher. So what you can do in reverse order, right? You can code female as 0 or male as 1 to get the value here in like suppose you code female as 0, right? So we'll get the value in positive, right? Or else sometimes we clearly mention absolute point-biserial. So in that case, we can, in either case, it will be positive. That's not a problem. Okay. Now next is, this is the sigma x. We have to use sigma x. So sigma x is population standard deviation of x. X means numerical variable. So what you have to do, you have to calculate the population standard deviation of this column, right? This numerical, because you can't perform population standard deviation this 1010 because it's a categorical variable. So you can calculate the population standard deviation here. Let's say it is coming anything. Okay, let me do right now 68, 50, 92, 68, 50, 92, and I have 72, 95, 40, 72, 95, 40. Oh, sorry. So I have to calculate the population standard deviation. So there is one formula, standard deviation dot P. So it's a 20.06. Okay. So this is, so here sigma x, you got 20.06. So what is the next? You have to calculate RPV. So you know what is the y bar 1, and so you have to do 61.67 minus 77.33 divide by 20.06 square root of 0.5 into 0.5. This P naught into P1. So whatever value you will get, that will be your final answer. Okay. Okay. So yeah, you can put the more there. That's not a problem. Now thing is that you have to in something, let me clear. RPB is equal to y bar naught minus y bar 1 divided by sigma x square root of P naught P1. I think in lecture by mistake ma'am wrote this as a small s. Okay, so don't treat as a sample. It should be population standard deviation. Okay, that is something you have to keep in your mind. That is the population standard deviation. Okay. You can use the sample standard deviation, but formula will get changed a little. What is the absolute point by C? Pawnee Sharma actually thing is that here if you see y bar and y bar not and y bar 1, right? So we'll get the things in negative here, right? If you will subtract y bar not minus y bar 1 in this particular case. But see, 0 I have coded on my own interest, right? Similarly, to get the values in positive, you can code this thing, the higher value with the 0. Let's say higher value is 77.3. So here I coded female as a 1. So for 1, we got 77.33. You can code that the 0, you will get the answer in positive. Or else you can go with the absolute point-biserial. Then if you take the modulus of that value, you will get the positive, means mod of -2 is 2. Okay. So I was explaining this thing, right? Yeah, normally we are going with the positive case here in point-biserial. So what I was discussing, yeah, all right. So here, this is you have to use the population standard deviation. If you want to use the sample standard deviation, formula will get changed little bit. Okay, one that important notice I told you by mistake, ma'am took small s, but that should be population standard deviation. Okay, you can use the sample standard deviation, formula will get changed. How, I will let you know. I think in one of the session, I think in Hindi session or somewhere, okay, let me explain. Suppose I am writing sigma square. I will write 1 upon n summation of xi minus x bar whole square. Yes or no? And sample variance, I will write 1 upon n minus 1 summation xi minus x bar whole square. So far, so good. Now, if this is the case, I can multiply this n with the left hand side. What I will get? N times of sigma square is equal to summation xi minus x bar square. I will multiply this left hand side. I will get n minus 1 times s square equal to summation of xi minus x bar square. So far, so good. Any doubt? This is clear? Correct? Okay. All right. So if you see, right hand side for both is equal, right? So can I say n times of sigma square is equal to n minus 1 s square? Means suppose I am saying x equal to a and y equal to a, then I can say x equal to y. Yes or no? All right. Then can I say here from here n times of sigma square is equal to n minus 1 times of s square? Correct? Yes. If this is the case, so this formula you can keep in your mind, right? So sometimes you suppose I gave you population variance or population standard deviation and sample, and I ask what is the number of observation, then you can directly tell me by using this. or suppose n is given to you, sigma square is given to you, and question is about sample variance or sample standard deviation, you can tell me. So this is something, right? You can, this is a very important formula you can keep in your mind. But anyway, let me explain what I'm trying to say here. So what will be the value of sigma square here? I will write n minus 1 divided by n s square. So what will be sigma? It will be square root of n minus 1 divided by n into s, right? So what you can do, x for numerical variable. So what you can do, if you will replace this sigma x with this part in the denominator one, you can use the sample standard deviation, right? So what will be my new formula if I will use the sample part, right? It will be this case, and here p naught p1 sigma x, right? So sigma x is what? Square root of n minus 1 divided by n sx. It will be, right? Correct. So it will be y bar naught minus y bar 1 divided by square root of n minus 1 divided by n into s of x. And you know, p naught p1 I can write n naught divided by n, n1 divided by n. Okay. Maybe you have seen this formula. Maybe you will recall it, s of x into square root of n naught divided by n into n1 divided by n, and it will go upside, then it will be n divided by n minus 1 square root of, okay, then what next I will get y bar naught minus y bar 1 divided by s of x, and it will be n naught into n, n1 divided by n into n divided by n minus 1, 1 n will get cancelled out. Okay. So the next thing, it will be y bar naught minus y bar 1 divided by s of x square root of n naught divided by n into n1 divided by n minus 1. So if you want to use, you know, sample standard deviation, then you have to use this formula, or else it's a simply go, maybe you have seen this formula, right? Or you can go with the population standard deviation, which is this formula. Okay. So it will be sigma x square root of p naught and p1, where p naught, you know, proportion of that category which is coded with 0, and proportion of that category which is p1 stand coded with 1. Okay. So for point by serial, Anuj, you can directly calculate, right? I will tell you, will let you know how. So suppose here, what is the thing? It's the 1 0 1 1 0 0, right? It's the direct thing you can do. Suppose I will write 1 0 1 1. Sorry, not like this. So 1 1 0 0. So in Excel, it's a directive thing. You can use correlation, CORR. So if you use correlation, so here it will automatically consider it has two categories only, and this one. So this will be 0.39 if you will solve by this formula, right? You will get the this is the value of point by serial correlation coefficient. Okay, I can verify. Let's say this, what is this? Population standard is 26. Okay, p naught p1 is 0.5 0.5, y bar naught. Okay, let's verify. Okay, so what is the y bar naught? Okay, y bar naught I got, it's 161.67 and 77.33. So let's take absolute value of 61.66 minus 77.33. Okay, 77.33. So this is our numerator part, and this is this, and square root. Okay, so this will be y bar minus y bar naught divided by standard deviation, and we have to multiply this part with 0.5. So it will be 0.5. So you can see this formula, this is same as with the correlation part, right? So you can say we got the same formula. All right, clear? No, it's not p not p1 is prefer for population and all. It's just a proportion. You can see, here I'm talking about what is the proportion of number of categories for which is coded with 0 with respect to n, and this is number of categories with respect to which is coded with 1. Okay, I think this is clear to all of you. Okay. Okay, fine. Okay. So what you can do now, okay? I have done the I think more or less everything. So what you can do, you can raise your hand. Okay. Yes. Anirudh, the y bar, not a y bar 1 is referred for the mean of category 0 and category 1. Correct. You are right. Okay. Then what you have to do, just do one more thing. You can raise your hand and we can, anyway, we have some 10 to 12 minutes. Then we can discuss the thing. If you have anything. Okay. So, okay, it's a request to everyone. Please do not make yours. Okay. It will be good if you will speak one by one. If anyone is speaking, please don't interrupt in between, because otherwise we will not be able to clear the doubts from others. Okay, so you are asking for the PDF. So let me share in the group itself. Okay, and later I will share with the support team. They will upload on the portal also. But as of now, if you are interested, then I can share here. And let me just give me a minute, and I will share in the chat box also. Okay. Yeah, 1 second. Just give me a second. Okay, don't worry about other people. I will share with the support team. Most probably they will upload on the portal also. Yeah, so can you confirm the chat I have shared? Are you able to access that one? Okay, all right, great. Yeah, fine. Okay, so I'm going, please, okay, just make the standard of the class, like please don't make yours, and it's a request to everyone. Just go. No, it would be good if you are going one by one. Okay, so yes.
Hello, sir. Please share
Pranav.
week 3 notes also this time, if you have it on your system.
Okay, I don't have. I think Bisal sir took the session, right? If I'm not wrong.
Okay.
Okay, I will ask to Bisal. He will upload it. Okay. Yes, Pranod, please go ahead.
Sir.
Yes, Pranod.
Sir,
Yes.
suppose we have got correlation as 0.74, and for second data set we have got correlation as 0.75, and for third we have got 0.76.
Okay.
So for this course we have to stick to the interpretation what you have shared.
Yeah, you can go with that. See, 0.75 will somehow suggest, right? So 0.75 means what? You are little bit close to 1, right? Somewhat you are close, you are converging to 1. Yes or no? That means
Yes.
you will say, yeah, it's a strong and positive. So that's not something like it's
But same will be with the 0.74 and 76 as well.
76 you can say it's positive. If it's 74 you can say it's strong. I think, see, Shraddha, I think you should mute, right? I told please maintain the things. Okay. So yeah, Pranut. So you can say 0.76 as a strong. 0.74 you can say in moderate or strong also, but you can go with the moderate also. That's not a problem. Okay, so mainly it's not like that it's 100% thing, but it will give you some rough idea.
For this particular course, we have to
correct. You can stick with this. That's not a problem.
And sir, one more thing,
yes.
I'm not just recalling it, but for the categorical data, we
Yes.
can use, I think, rank correlation to quantify them.
Yes, Bruno. There's rank correlation, something like, but we are not doing this.
Okay.
So you can see rank correlation and something that 1 minus 6 formula is 1 minus 6 summation di square and divided by something, but we are not doing. So it's here in stats on what we are doing, we are creating the foundation for no basic things. Okay, that's why we are we focusing very basic. All right.
And one more thing, sir.
Yes.
It is not related to this particular course itself, but rather to a large data science perspective. I am asking that when we are considering any data set for machine learning purpose, the data are very large. So in that case, if we have to calculate correlation, then we should go for the population one itself.
No. For correlation, there is nothing mentioned population and sample. It's
covariance.
No, it's not like that. Sometimes it will be clearly mentioned whether it's a population and sample.
I'm asking from the you can say that from practical aspect, not from the course point of view.
Okay. So actually, thing is that why we are using actually n-1. There is a reason behind it. I told you that unbiasedness property and all, right? So unbiasedness means whatever the estimator you have, it should be unbiased. It shouldn't be biased.
That blue property
Correct. So if you are using n-1, let's say for variance, right, s square, then it gives us the unbiased estimator for your population variance. So that's why we are using n-1 in the denominator. Okay. So those are things we can discuss it later. It's not a problem. But yeah, there's a reason behind it why we are. So you should go with the good estimator, not the estimator which is giving you some bias in your study. All right. Okay. I hope I have given the answer. Okay. Yeah. Yes. Deepans. Yeah. Please go.
Sir, will you
Deepans?
send the link for this live?
See, I told you it's already on your calendar. You can check. Okay. So I will go one by one. Yeah. Deepans, please go ahead.
Can I ask regarding question doubt? Sir, can I ask a question regarding week 3 graded assignment?
Yes, Deepans. What is your doubt?
Sir, actually, there is a question in which they say that initial mean and initial standard deviation they have given, and they say that one value is taken as 10 instead of 13. So, what is the new variance they asked?
Okay.
Sir, upon doing all the calculations so many times, I'm still getting the answer out of the range. Answer range is 7.54 to 118.14, but I'm getting 118.7 something.
No, it will not be the case. But actually, for everyone, numbers are different. Okay. So you can redo your calculation. Just recheck.
Sir, I have done the calculation again and again, and I'm still getting. I think there might be a change or range difference.
No,
sir, I use calculators.
Okay. Maybe you are taking the round of things. Okay. Round
Sir,
of things you have to take.
I did not even do handoff or round of calculations. I took up to whatever decimal places I got. Everything I did not do any round of. Pure calculations I have done using the calculator or even computer.
So you are getting for the first part or second part? Because for sample thing, it will take some time to calculate for me right now.
Sir, can I mail you this question and I can mail you the solution?
Yeah, fine. You can mail to me, or if you are okay with the discourse or discussion forum, I think.
No, sir, I'm not okay. The discourse, I don't think any teacher is active on that. Just all the students are continuously chatting, and I don't feel it as useful.
No, okay, so
discourse. Actually, I'm not on discourse until now. I haven't qualified, so I don't think I have the access.
Discussion
I thought you were saying about the forums, discussion forum.
Yeah, discussion forum is also fine. That's not.
No, sir.
You can simply mail to me. I will solve it later because right now it's not problem for me. But
yes, sir. It's late. So, sir, can you give me the? I will message you tomorrow if possible. For you.
Okay, so you can simply mail to me. It's prasant@study.it.
Okay, sir. Thank you, sir.
Kasika, yes, Kasika, please. Kasika, I'm pronouncing correct, right? Please correct me.
Sir, can you explain the last part you just taught?
Which part?
The last part you just taught.
Where you are getting difficulty?
Sir, all that. Not this. In the last.
This formula change?
Yes, sir, all of this that you did. Yes, sir.
Okay, actually, so what I told, actually, this is the main formula. Okay. One more thing in my lecture, by mistake, ma'am took S, but I mean, ma'am took S, ma'am wrote S instead of this sigma, but it should be population standard deviation. You can use this sample standard deviation, but formula will get changed. So thing is that I can write this population standard deviation equal to square root of n minus 1 divided by n into standard deviation, right? This one was clear to you? Okay.
Okay. Ma'am wrote S because she afterwards wrote that P naught into P1 का जो root है, that is n naught upon n minus 1. So she considered it as n minus 1 in the
This one,
denominator.
right?
Yes, yes. That's
Okay,
why
then
she
it's
wrote
correct.
S.
Yeah, then that's why it's correct. That's why I told you, right? If you can use the population standard deviation directly, or else you can replace this sigma x with this quantity, okay, which we got from here, right? We have this sigma square 1 upon n summation of xi minus x bar square. All right. Then I can write n sigma square as summation of xi minus x bar and here. So I will get n sigma square as n minus 1 times s square. Okay. Then from here I can write sigma square as n minus 1 divided by n s square. And then sigma, if I will take square root on both sides, I will get sigma x as the square root of n minus 1 divided by n into s. So this sigma s I can replace with this quantity. I have replaced and I have done something, some manipulation and this and all things. So then your n will get cancelled out, and at the end you will get this. So there is no need to keep in mind both formula. You can keep any one formula, but normally I'm okay with this one. I mean, for me itself. Okay, is this fine, right?
And okay, so I understand. And the other doubt I had, so you were explaining with the spreadsheet. So I had a doubt whether in the exam, that is a July 7th exam, will they ask us to do any operations on the spreadsheet?
Nothing. That spreadsheet just for your practice, right? The same thing, the theoretical thing, how you can perform on Google Sheet or Excel sheet. That's all.
So actually, even though ma'am teaches in the videos about spreadsheet, but actually that won't be asked, like any whatsoever.
Yeah. So it's not possible from the TCS things, right? We have to give the Google Sheet to all of you. So thing is that, see, normally whatever the theoretical thing we are learning, how we can perform on Google Sheet. Normally, if you move to Stash 2, then you will see how you can do the things on Colab using some Python and all. The thing which we are discussing theoretically, how we can do by using any all right, clear?
Yes, sir.
Yeah, excuse me.
Yes.
Regarding there was a regarding what the previous person said about the sample variance question. I have seen the week 3 graded solution of this. This is like just the general derivation of it, but I cannot understand like about the entire derivation.
No, through Torsi, right? Correct pronunciation.
Yeah, exactly.
So actually, why we have given the general, because the questions which you will see on for a grade assignment, right? It's a different number for every people.
Yeah,
okay?
exactly. Yeah, it's
correct.
okay.
So that's why we gave you. Okay, I will explain you. That's not a problem. Okay, just give me a second. Yeah, I will open the. Okay, all right. Just give me a second. So this is this one you are talking about, right?
Yeah, it's actually a derivation. So
yeah, one
I
second.
cannot.
That's not a problem. Yeah, give me a second. Problem. Okay, should I write or should I explain here?
No, exactly. I'm just telling you about the. No. Can you please show the sample variance thing, not the mean?
One second. Don't worry. I'm just see here. I will explain you what is we are doing. So T dash represents. So let me download so that I can edit the things. Okay. Just give me a second. If I will able to open this part, then I can edit this thing. Yeah, give me a second. All right. No, I can edit the things. Yeah. So here, what we are doing, we are subtracting the wrong observation with the and adding the correct observation, right? So this T dash will represent the addition, and this is the T dash addition of the correct observations, right? I mean original data. Correct? Now, so in variance part, Okay, so I am hoping this is clear to all of you, right? We
Yeah,
have
yeah,
given
of course.
one. Okay, now. So in variance part, if you see, so this expansion is clear?
Yeah, no, yeah, exactly. There's one term I feel is missing. That is
Which
2 x bar n by x bar, that sort of thing. I'm not able to find out exactly.
You are not getting
Oh,
this part.
yes.
See, this part is okay, right?
Yeah, exactly.
Okay, if this is the okay, if you see, so if you take the summation inside the bracket, what I will get? Summation of xi square.
Yeah.
Minus 2 times of x bar, summation of xi.
Exactly, yes.
Plus summation of x bar square, right?
Yes.
Okay. Now this is the summation of xi square minus 2x. So what is the x bar? Here it will be 1 upon capital N summation of xi.
Yeah.
Okay. Then can I replace summation of xi with n times of x bar?
Oh, yes.
So it will be n times of x bar.
Right.
Plus what you are doing here, you are adding x bar square up to n times, right?
Yes.
This is a constant, right? So this is, I can write n times of x bar square.
Oh, okay. Now so then you can just subtract.
Correct. So it will be 2n x bar square plus nx bar square. Now it will be summation of xi square minus n times of x bar square. So here you can use the correct mean, and here you have to use the you have to subtract the square of wrong observation.
You have to
add
change the value of x1, xi
correct
whole square.
like this. So this is right.
सॉरी फॉर डिस्टर्बिंग यू सर, क्या वापस समझा सकते हैं इसका? लास्ट वाला हमको समझ में नहीं आया, इसको ऊपर से यार
This one
सर फर्स्ट सही.
Okay, so if I can take summation inside the bracket, it will be summation of xi square.
Yes, sir.
Okay, since summation is for I, then I will apply here. If you have 2xi x bar and summation, then I can simply write 2x bar summation of xi, because correct.
Yes, sir.
And if you can simply write summation of x bar square. So here what you are doing here,
x bar into x bar plus x bar plus x bar plus x bar.
So it will be n times of x bar.
Yes,
correct?
Sir.
Now this summation of xi I can replace with nx bar.
Yes, sir.
Correct. So if this is the n times x bar, so here we have 2x bar. So I will write summation of xi square minus 2nx bar square.
Yes, sir.
Plus x bar square. So here 2 minus 1 will be minus.
Yes, sir.
Understood? Correct.
Yes,
Okay.
sir.
Okay.
Thank you, sir.
This is clear, right? I think. Okay. Okay. Fine. So Shivam Kumar, yes, Shivam, please.
Hello, sir. Yes, sir.
Yes,
Sir,
Shivam.
sir, like we just you taught about this correlation coefficient, and you told that it is a relation between x-axis and y-axis. How is this different from slope of a line, sir? Can you please explain, sir?
Slope of a line?
Yes, sir.
Okay. So what is the slope? Slope represent?
So change in y-axis upon x-axis. So like we both, try to find the same thing about this also, sir. Is there something like that, sir? The slope of in statistics?
Okay. So okay. First of all, what kind of slope you will get? So this here, see, in correlation coefficient, what kind of values we are getting, or what kind of graph we are getting?
Linear graph, sir.
Okay.
So, sir, if we have a linear graph, we can have a slope of that also.
Okay.
Is there a relation between this correlation and some slope?
See, no, it's not like that. You can simply see, what is the, first of all, if you see from the slope of line, what are the thing we are getting? Normally, it will give you the direction and steepness of the line, right?
Yes, sir.
Correct. And what kind of relationship is there? Y equal to, let's say normally we are taking y equal to mx plus b, right? So what m will represent your slope, and b represent normally intercept, right?
Yes.
Okay. And what is that meaning of that slope? Means if you are going to change in your variable y, that will reflect 1 unit change in your independent variable, right? And what is the correlation tells you? Correlation tells you what is the strength and direction of linear relationship, right? Rather than steepness of. Okay, so there is a one relationship in correlation slope and let me share my screen. In slope and correlation coefficient, that is something we are not we haven't done in stats course. So that is something you can see while you will move to the regression, simple linear regression and all. So
Yes, sir. Yes, sir.
it's
There
y
it
equal
is,
to
sir.
mx plus b, right? So this is the slope. Okay, so normally we are slope, we are denoting r times r is correlation coefficient s y divided by s of x. So this sy stands for standard deviation of x and y, and sx for standard deviation of x. So this is not the same. There is this linear relationship will be having. Okay, so
Okay,
basically
sir.
this slope is there. Okay, this is
Okay,
something
sir.
we'll see when you will move on ML part. You will see the linear regression and all. That is something we'll learn there. Okay.
Okay, sir.
Okay. So Afrin, yeah, please go.
Sir, I had a doubt in graded assignment week 3.
Yeah. Yes.
Question number 8.
Question number
8.
8th. Okay. So
8.
did you see the solution PDF?
Yes, sir. I'm not able to understand.
Okay. Let me share my screen.
The question says in a deck there are cards.
Okay. Where you are getting difficulty?
Sir, I'm not able to understand how did we derive that formula, and is that applicable for any number of cards?
Yeah. So you can see we have mentioned we have card number from 1 to n, right? Okay. N can be anything. For you, maybe let me see. For me, what is the grade assignment for me? Let me see.
What I mean to ask is if it is odd or even.
No, it's fine. That's no problem, right? See, for me, it's a 29. For you, what is the number?
44.
Yeah. For you, it's even. For me, it's odd, right?
Yeah.
It's not a problem. It's in general, right? So it's if 1 to n, such that number of cards of a given number is same as the number on the card, right? That means what? Number of card means we are talking about in terms of frequency, right? Number on the cards means 1, right? So 1 is 1 times, 2 is 2 times, up to n is n times. So mode will be n, right? Because this card will occur more frequently. Yes or no?
Yes, sir.
Right? Then what will total number of observation? We know summation of all the frequency is equal to total number of observation.
Yes, sir.
Okay. And mean is what? These things, right? You know, this summation of fi xi divided by summation of that's something we have done. Yeah? For here, for example, you can see for n equal to 42, we have taken. So what will the mode? Mode will be 42, right? All right. Fine.
Yes, sir.
Okay.
And the mode will be the number which is the greatest, right? Because
yeah,
that is the
because
number which is
see
appearing on the card.
This card occurs 42 times, right?
Mm-hmm.
So that means mode will be 42. Clear?
Yes, sir.
Oh, great.
Thank you.
Thank you. So after you, Roshan. Yes, Roshan.
I have a doubt in practice assignment 3.1.
Okay, which question?
Question number 3, sir.
Question might be different because if you refresh, you will get the different set of question. Can you tell me the question?
Yes, sir. The sample mean and the sample variance of 5 data value are respectively 30.
One second, let me refresh because whatever you are saying, I'm not. It's not visible for me. So it's a large question or it's a small question?
It's a small question, sir.
No, okay. So what you are saying? The sample mean what? Can you tell?
The sample mean and sample variance given that 13.6 and 25.8. Okay.
Okay. One second. Let me write. Maybe I'm not getting the question in my portal because if after each refresh you will get the different set of question, right? I'm hoping you are aware about that. So I don't think I got the question. Let me refresh once.
Okay, sir.
You can try.
Sir, you already explained this question in the last session, sir. You can check on YouTube also.
Okay. Okay, minimal. Let me give you some idea. Yeah, yeah. So can you tell me the question? What is the question?
Yes, sir. The sample mean and sample variance are 13.6 and 25.8.
Okay. Sample variance is 25.8.
25.8. Yes,
Okay.
sir.
Okay.
If three of the data values are 7, 13, and 20,
okay,
then what are the other two values?
Of 5 data. Okay, it should be 5 for 5 data, right? You know,
Yes.
you mean let's say 2 are A and
A
B
or B.
for it.
Yeah. Yes,
let's
sir.
say I have 2 A B. Okay, so what is the mean? Mean will be 7 plus 13
13.6
plus 20 plus A plus B, right? Divide by 5. This is the formula for mean. See,
Yeah.
what you can observe here, you have two unknown quantity. All right. Okay.
Yes,
And
sir.
you can get two equations with the help of this part and with the help of this part. And basically, you have to solve the equation. I will give you the idea. So what will be there? It will be so this part, numerator part, 13 plus 7, 20, 20 plus 40 plus A plus B equal to 13.6 into 5.
Yes, sir.
What will the value
It
of
is
this?
40 plus x matlab a plus b is equals to 68.
68.
And a plus b is equals to 28.
Yeah, you know how to do this. Then what is the problem?
Yes, sir. But when I have solved, there is a quadratic which I am unable to solve that, sir. So can you
Okay,
please solve for me?
you need only quadratic part. Can you tell me the quadratic one? I think you need quadratic
Yes.
while you are solving the, I mean, for sample one,
Yes,
right?
sir.
Means you have to
Yes,
do
sir.
basically, I will tell you, you have to do 7 minus 13.6. Okay, what is the sample? This is 1 upon n minus 1 summation of xi minus x bar square, right?
Yeah. Yes, sir.
So what is the xi minus x bar square? So xi is 7 minus x bar is we know 13.6 plus what is the next observation? It is 13. Correct?
13.
Plus 20 minus 13.6 square plus
Yes,
A
sir.
minus 13.6 square plus B minus 13.6 square. That is something we have to do, right? Divide by
Yes,
4.
sir.
Okay.
Yeah.
Okay. Can you tell me the
That part
quadratic one?
84.88. 84.88.
Make sure it's a correct one. I'm not sure whether you
Yes,
got
sir.
84.88.
A minus 13.6 square.
What is
Plus
the 84.88? What after this?
the quadratic which I have solved that
No,
from
84.88 what equal to minus what you got?
no, sir. 84.88 plus in bracket a minus 13.6 whole square
okay
plus b minus 13.6 whole square is equals to 103.2.
okay.
Okay, sir.
After this you are
And
asking, right?
yes, sir.
Okay, so the simple thing, right? So you have to expand this part, right? So what you will get 84.88, make sure this is the correct. So this will be a square plus 13.6 square minus 2 into 13.6 into a. Clear?
Yeah.
Plus
Yes, sir.
it will be b square, or else I will suggest you one key idea, right? Rather than this b square, what you can do, what is the value of a here? A will be 28 minus b.
Yes, sir.
Correct. You can simply replace here 28 minus no, not let's talk about a. So what is the value of b here? 28 minus a, right?
Yes,
You can
sir.
replace this b as 28 minus a. You will get this case.
Yeah.
Okay. Now what we will do, 84.88 plus a square plus 13.6 square minus, you can simply multiply this 2 times 13.6 a. Now what you will get here, 28 minus 13.6, what will be value of this? 14.4. Correct. So you will get 14.4 minus a whole square equal to 103.2. All right. Then you will get 84.88 plus 8 a square plus 13.6 square minus 2 times 13.6 a plus 1 square plus a square minus 2 times of 14.4 into a equal to 103.2. So here you can see you will get some value, this will be added, right? This value will be added. You will get 2a square something this a and some this, and this part plus this part plus this part you can take and you can subtract from the right hand side, right? Then you will get some equation in terms of, let's say, a square some part into a and some part into constant equal to 0. Then you can solve for a. Once you will get the value of a, you can substitute here, you will get the value of b. Clear?
Okay, sir.
Yeah, just try once. If you are not getting, we can have a more discussion on this. All right?
Okay, sir. Thanks, sir.
Okay, then see, Kasika CT is already, see, every graded assignment you can find under the supplementary content. There is one subsection called graded assignment solution, and you can access the solution from there itself. It's already on the portal. All right. Okay, fine. Okay, then. Okay, I think we have covered the content of week 4. I'm hoping you got the idea of week 4. Let's meet in the next session and we can discuss.
Hello, sir.
Yes.
Excuse me, sorry to. Could you please once again visit to the same question in which we have to by mistakenly we change one data entry and calculate the sample variance.
Okay. So what is your doubt?
Sir, I went through the solution, but I used the method of using sample point data summation of sample points from 0 to 9 and plus our extra entry, that is change entry, that is 16. In my question it was 16.
Okay.
So by using that formula I derived, but somehow I didn't get the correct answer.
No, I didn't get your question. What you're getting?
Sir, could you please open the solution? Open the solution. Yeah.
Okay, all right. One second. Okay, so here, right?
Yes.
Yeah. What is your doubt?
Yeah. So in this question, yeah. So in this question, I have to.
Okay. Suppose this is the n. This is the sample mean. This is sample standard deviation given as, I think, x stands for.
No, sir. No, not this. The change in data entry. The previous one.
Yeah, that is the question actually.
Yes.
Yeah. Okay.
Yes. So.
Yeah. Good.
Yeah. So here you before expanding the term, in the solution, the next line in the solution, the first line, sample variance is equal to, okay. Yeah. So in this term, I used.
Okay. You took summation I is equal to 1 to 9.
Yes, sir.
No, but how? Why? If you had 10 observations, right?
Yes, and one entry I just calculated manually.
No. What is meaning of 0 to 9? I didn't get your.
No, 1 to 9, not 0 to 9, 1 to 9 plus our x 10th value, means the change value with me.
Did you take the square of that part?
Yes, sir. No, sir. In my question, I have to calculate standard deviation.
Okay, even though you have to take a standard deviation, so it's you can calculate the sample variance.
Yes,
and then you can take the square root at the end. That's.
Yeah. So in my so I did like I 1 to 9 xi minus x bar whole square plus x minus x bar, the change entry minus our change.
You have to take the square root. You have to take the square. So if you see what is the formula, it's a xi minus x bar square, right?
Yes, sir.
Then at the end you will get this part. Even
no,
though
sir, I just calculate the summation difference of first 9 values.
See, you are saying 1 upon n minus 1 summation of xi minus x bar square, right?
Yes,
so
sir.
I is equal to 1 to 10. What you are saying? You are saying you took summation I is equal to 1 to 9.
Yes.
You did xi minus x bar square. Then you did xi minus x bar, right?
whole square.
Whole square.
Yes.
Correct. So
Yes.
this is for
Changed value. So first I calculated.
But you have to subtract the wrong one also, right?
Yes, sir. First.
I think
First
standard deviation there will not be change any, because if there is slighter change, because it would not vary also. No change.
No, that is not case here. It's we are talking about this part. Yeah. Okay. So
yeah,
okay,
sir.
make
Sir,
sure.
sir, let me finish. Let me complete my side first.
Correct.
Yeah. So in first part we have wrong value of standard deviation and wrong value of data entry, right? So I calculate the standard deviation. So yeah. So I calculate I is equal to 1 to 9 x minus x square ka value. First term ka value.
That is the mistake you made.
Okay.
Actually, what is the case? Okay, suppose I will explain. Suppose I want correct mean. I have to calculate the correct mean, right? Then what I will do? So this will be my original mean, right? Let's say this is something m I am getting, right? Then what will be summation of xi m into n, right?
Yes, sir.
I have to use the correct mean. So to get the correct mean, so what I will do? I will subtract the wrong one and I will get add the correct observation, right?
Yes, sir.
That will be m into n.
Yes.
Not m into n. Something else. Okay. Let's say summation. Let's say I'm denoting x dash. Okay.
Okay.
So you have to do x dash divided by n. This will be your correct mean, right? I'm writing x bar c. Okay. Now, if you want to use now here what you are doing, correct, you are going to use for the wrong one, right? Then here you have to use the correct one.
Yes,
so that's
sir.
why, okay, it's a very simple thing, right? So to get the variance part, 1 to n, xi minus x bar square, to get the correct thing, what you have to do, you took summation I is equal to 1 to 9 xi minus x bar square, right? Then what you can do, plus that is the confusion here. Okay, that's why we did this part. If you will expand, right? So what you have to do, you can use directly square of the you can get the directly square of the correct observation. Are you getting? See, if you will expand this formula, then you will get summation of xi square divided by n, correct?
Yes.
And I think what at the last minus n times, okay, minus n times of x bar square divided by n minus 1, right?
Yes, I got this value also.
You got this, right? So what
Yes.
we have to do, we have to do the correct, we need the correct xi square, right?
Yes.
To get the correct xi, what we did this part. So to get the squares part, what I will do, xi square minus, let's say, wrong square plus correct square.
Yes, yes, sir.
Correct? That will give me, let's say I'm writing x dash square. Okay. Now here what will we use? I will use the correct mean, because here I have used the, so here you will use the x bar c square, right?
Yes, sir, because we have to calculate with the correct mean.
So it will be x dash square minus n times of x bar c square n minus 1. Then whatever the value you will get, it will give you the variance. And if you take the square root of that value, it will give you the standard deviation. Clear? I think there might be some calculation mistake.
Sir, I did it 3 times before the submission.
Okay, then I would request you, would request you can simply mail to me, then I can cross check, or you can simply post on the discussion forum. Any one of from our side or TS can cross check, because it will be little bit difficult to do right now. Then there
Fine, sir. So I will mail you my solution. So please guide me.
So that, yeah, correct.
Wrong.
That's not a problem. Yeah. All right.
Okay, sir. Could you please tell me your mail ID, sir?
It's simply prashant@study.iatm.ac.
Prashant, sorry.
@study.iatm.ac.in.
Study dot
iatm.ac.in.
Okay, sir.
All right.
Okay, sir.
Okay. All right. Yeah. Or else you can simply post on the discussion forum. That's all. Okay. Some people are asking on the grade assignment 3 PDF. See, you can simply go under the supplementary content. Under the supplementary content, there is one section called. Okay. Let me show you so that. Okay. So you can go under supplementary content. there is supplement, there is lots of subsections: lecture, PPT, PDX slides, graded assignment solution. If you click on graded assignment solution, it will be click here to view the graded assignment solution PDF. Then you will see this PDF part. Okay, so till now we have uploaded till week 3. Okay.
Sir,
Okay. Yes.
I'm sorry, I'm asking the same question again. Actually, in the 8th question, the deck of cards, I wanted to ask why, when we are calculating the sum of observations, we are dividing by 6. This was the doubt.
Okay, okay. That is the formula, friend. Okay, that is the
So we need to
formula.
remember that. We don't.
You can, or you can derive. Actually, that is the something we are getting with the series. Okay, this part you are talking about, this part, right? This
Yes, yes.
part.
Where did we get
Okay.
the 6
Yeah,
from?
I will tell you the reason. What is the reason? Okay, what you are saying here? Seeing here. Okay, can you tell me what is the addition of 1 plus 2 plus 3 first and natural number? It's n into n plus 1 divided by 2.
By 2.
Okay? That is formula. So here if you see, if you will add 1 plus 2 plus 42, so 42 into 42 plus 1 divided by 2. Correct? So if you see here, what you are getting, 1 square plus 2 square plus up to 42 square, right? This is n square. So for this we have formula n into n plus 1, 2n plus 1 divided by 6. That is the formula.
Oh, okay. Okay. We already have the formula for that. Okay. Based on that, we are calculating.
Correct. Correct.
Okay.
Correct.
I thought we had derived it based on this
No, it's
equation.
not derivation. It's not derivation.
Okay. Thank you so much, sir. Thank you.
Okay. Okay, then I think we can close, right? So we can. Okay. Fine.
Yes, sir. Thank you. Good night. Thank you.
Thank you. Good night.
This into the
Sir,
RS.
can I ask?
Yeah, I think this is, yeah, please go ahead.
Sir, I wanted to ask
Sir,
when you were explaining the bar graphs, that's also called a graded bar. When you up to
There's some
bar.
background voice. Your voice is breaking, I think.
So my voice is breaking.
Yeah, now it's fine. Yeah, go ahead.
So in the beginning, when you were explaining those bar graphs, they're also known as composite bar graphs, no? When you add up together.
Yeah.
Okay. And the difference between one bar where there was a gender and male and female bar, and the one in percentage.
Correct.
Yeah. So does the difference is that one is in percentage, you called it something
Another is in count. Yeah.
count also. So one keeps in percentage, one just keeps in normal integer value.
Correct. One will give you just a count, let's say 44 female. If you simply interested in number of female, it will give you some single bar, right? But inside that bar, suppose you have some category. That's why it's called a stacked bar chart. Okay? You are just dividing those. Okay? You are clearly
That's all
mentioning.
between them.
Yeah, you are mentioning those categories clear.
Okay. Thank you, sir.
Yeah, thank you. Okay, then all right. Thank you all. Bye.
Thank you, sir.
Good night, sir.